All right, so before we go any further, I just want to summarize some of the vocabulary that we're going to be using. Now, we already used some of this vocabulary in the first example. So we use the terms matrix, right? We use the term matrix. We use the dimensions of a matrix, and we talked about elements or entries in a matrix. So let's just summarize what we know so far. So first of all, a matrix is just an ordered rectangular array of numbers. And the size or dimensions of a matrix is just the number of rows by the number of columns. So in the example we just saw, we had a 3 by 4 matrix, which meant that it had 3 rows and 4 columns. But always remember that the rows come first. The rows always come first. So when you see the dimensions of a matrix, it's always rows by columns. All right, we also use this term in the first example, element of a matrix or entry in a matrix. And it's just one of the numbers in the matrix. Now, oftentimes we need to refer to a particular element in a matrix, and we want to give it a name, sort of a variable name. And so we use a lowercase letter and give it we refer to it by row and column, where this I and J, the I is the ith row and the J is the jth column. So again, in this subscript on this name for the element in a matrix, it's the row number first and then the column number. Okay. So for example, let's just look at that, because this is kind of abstract the way I have it written here. So let's look at an example. Let's say we have a matrix A. We're going to call this matrix capital A. Usually matrices are named with capital letters. And let's just say the elements are 1, 2, 3, and 4. Okay. So then A11 is the element in the first row, first column. So that's going to be 1. A12, okay, that's the element in the first row, second column. So that's the number 2. And so on. A21 refers to the second row, first column, and that element is 3. And then A22 would be the element in the second row, second column. So that element would be 4. All right. So again, the row number comes first in the subscript. All right. So let's talk about some particular types of matrices that we might be referring to. A row matrix. A row matrix is basically a matrix that just has a row, one row. So if it just has one row, then its dimensions are 1 by n, right? Because it has one row and it can have any number of columns. All right. So for example, let's look at an example here. So for example, let's say we have the matrix, let's say we have this matrix. It looks like 4, minus 1, 6, 3. Okay, so it's a 1 by 4 matrix, right? It's a 1 by 4, 1 by 4, and it's a row matrix because it just has one row. So we would refer to this as a row matrix. All right. Now, a column matrix is probably what you would expect. It's a matrix that is just one column. So if it has just one column, then it can have any number of rows, n, but it has one column, so it's an n by 1 matrix. So let's look at an example of that. For example, let's take a matrix that looks like 2, -8, and 3. Okay, it's one column, and that's it. So it's, in this case, it's a 3 by 1. So this is a 3 by 1 column matrix. Column matrix. Okay. All right. Square matrix. A square matrix is a matrix that's square. It has the same number of rows as columns. So we can say that its dimensions are n by n. So we don't really care how many rows and columns it has, as long as the rows and columns are the same number. So let's look at an example of that. For example, if we have a matrix that looks like, let's say, 2, -3, 1, and then let's say 0, 4, and -1, and let's say 6, 5, and 0. Okay, so there is a matrix that has 3 rows and 3 columns. So we would say this is a 3 by 3 square matrix. Oops, square matrix. All right. All right, one more thing I want to mention is a zero matrix. A zero matrix is just a matrix that's all zeros, and it can be really any size. So let's look at an example of that. Example. We could have a 3 by 2. So it's 0, 0, 0, 0, 0, 0. All the entries are 0. Okay, so this is a 3 by 2 0 matrix. Okay, so you might be wondering, well, why do we care about a 0 matrix? Well, sometimes we just refer to this as 0. Now it could, in this case, it's a 3 by 2. These 0 matrices could have any size, but the 0 matrix is effectively the additive identity. So just like 0 in the land of real numbers, 0 is the additive identity, because we can add it to anything and you just get the same thing back, right? So if you add 3 plus 0, you get 3, right? So it's called the additive identity. It's going to be more important when we start talking about the algebra of matrices, but essentially you can add 0 plus a or a plus 0, and you just get the same thing back. You get the identical thing that you added to 0. You get that back. All right, well, that takes care of some of the vocabulary, and I'll meet you in the next video.